All right. Now we will be looking at elimination reactions. So, on the elimination reactions, what are the elimination reaction? Elimination reaction compounds. Now we are doing what? We are converting what? Compound with single bonds. We are converting compound with single bonds to what? To compound with to compound with what? With double bonds. So now this one we are converting compound with single bonds to compound with double bonds. So now we have different types of single bonds. We have different types of we have different types of elimination reaction. What types of elimination reaction do we have? We have dehydrohalogenation. We have dehydrohalogenation. Number 2, we have dehydration. We have dehydration. And then number 3, we have dehydrogenation. And then the other one types of elimination, we can basically say it's what? It's cracking. We can basically say that it's what? It's cracking. But this cracking are divided into two later on. The first one is what? Is thermal. The first one is the thermal cracking. We have the thermal cracking, and we also have the catalytic cracking. So we are going to be discussing each and every one of this one. Remember, guys, if you see this one if you see the reactants, the single bond becomes the reactant, and then now at the end you find that you have some double bonds. You have some double bonds. You have some double bonds. And then you must know that if the reactants are double bonds and then the product, you find that the products are what? The products are single bonds. Then you must, when you find that the reactants are single bonds, the products are double bonds. Therefore, you must know that that one is elimination reaction. So let's get to each one of them step by step and understand what is what. Let's start with them. Dehydration. Let's start with dehydration. So dehydration, to hydrate, it means to add water. To dehydrate means to remove water. To eliminate is to remove, guys. So we'll be having an alcohol. This is our alcohol. So this alcohol, we have an alcohol like this. We have an alcohol like this. We have an alcohol like this. This is our alcohol. And then we are going to be removing this alcohol. We'll be removing water from this alcohol. Before we do anything, guys, we must know that we follow the ZZ rule. We must know that we must follow what? The ZZ. In the ZZ. If you don't know how to write the spelling, just say ZZ rule. You see, man. So ZZ rule. So what does the ZZ rule say? The ZZ rule says that we remove the first thing we do what? We remove the hydrogen from the carbon with the. So now let's continue. As I was saying, that we have the ZZ rules that says the carbon, we remove the hydrogen from the carbon with the least number of hydrogen atoms. If you find that they are taking something, they always take from the poor, but they always give to the rich. It's just politics. Let's forget about it. So in dehydration, we remove the hydrogen in order to form a major product. In order to form a major product, we are going to do what? We are going to remove the hydrogen from the carbon with the least number of carbon atoms. How so? We are going to say 1, 2, 3, now 4. We are going to analyze where are we going to remove. Yes, we know that we are going to remove this one, this OH. So which hydrogen are we going to remove? Are we going to remove this one or this one? we remove this one because this carbon have the least number of carbon atom. Initially 1, 2, and then this one got 1, 2, 3. So we remove to the carbon with the least number of carbon atom. What are we removing? The oxygen. Since we remove between carbon number 2 and 3, therefore between carbon number 1, 2, and 3, we are going to have what? A double bond. Now we are going to have a double bond and have something like this. Hydrogen, 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 hydrogen. So now this is what we have. And then don't forget that the reaction must be balanced. We removed water. We're going to say plus H2, H2O. And then this one becomes the dehydration, the removal of water. The water is being removed as a product, and then we have double bond. We started with single bonds, and then we end with what? With double bonds. So this is what we call the dehydration of the dehydration. All right, guys, let's move to the next one now. We have we have dehydrohalogenation. Your first bond, imagine if your first bond is dehydrohalogenation. How cool is that, guys? Hey, dehydrohalogenation. That's so nice. All right. So that's the name you can give to one of your daughters or one of your sons. All right. So what is dehydrohalogenation? Like the word speaks for itself. We are removing what? We are removing a hydrogen and a halogen. We are moving a hydrogen and a halogen from a compound. We also start having what? Single bonds. 1, 2, 3, 4. We also start by having single bond Br, and then we have H, we have H, and then we have H, and then we have like this hydrogen. Guys, don't be lazy to write this one in the examination name. And then you must also, so now we are going to do what? This one is going to react. It's going to react with what? Always, guys, it always react with sodium with a strong base, sodium hydroxide. So this one reacts with what? With a strong base. It's a reaction with what? With a strong base, concentrated strong base, which is what? Sodium hydroxide. It can be sodium hydroxide, or it can be potassium hydroxide, or it can be lithium hydroxide. So this one, it's always react with this, guys. So you must take this one into consideration. It's one of the reaction conditions we have. Right. So now we are going to be removing now. What are we going to be removing? We are going to be removing a hydrogen and a halogen. So let's go ahead and do that. 1, 2, 3, 4. And then which one are we going to remove to form a major product? In order for us to form a major product. A major product is formed when we follow the ZZ rule. I'm going to show you the major product, and then I'm going to show you a minor product. So in order for us to form a major product, we are going to be removing this Br, this halogen, and what? And this hydrogen. And then from there, we are going to have what? Between carbon number 2 and 3, we are going to have a double bond. And then it's going to be 1, 2, 3, 4, 1, 1. Remember, guys, you must be careful about this one. That H2H. You must be careful about the number of bonds around the carbon. Don't just write any. Remember that each and every carbon must be bonded 4 times. So now we are going to say plus what? This Br, this B is going to bond with what? It's going to bond with the sodium, or it's going to bond with the K if it's K. If it's lithium, it's going to bond with lithium. And then we're going to have BrNa. And then plus what? This hydrogen is going to bond with this hydroxyl group. And then we're going to have H2O. Guys, you must always take this one into consideration that in dehydrohalogenation, the product is always what? 3 product. Water plus this one and plus the alkene. So you must take that one into consideration. Reaction condition, there must be what? A strong base and what? And heat. heat. So I didn't mention, guys, the reaction condition for dehydration. Please allow me to do that. We have the reaction condition of what here? Of heat. Heat, we use heat to eliminate water, to make water to escape. Right. So now that is what we call that is what we call the dehydrohalogenation. So let's form the minor product now. How are we going to form the minor product? Let me show you. Just in this space, we are not going to be following the ZZ rule. The ZZ rule. Remember, Markov-Nikov is in addition, ZZ is in elimination. When we form that one, we are going to be removing this one and this one. We remove the one with the most. It's opposite for the major product. So it's gonna be this one. The double bond will come here, and then we're gonna have something like this. And then this one will be our minor, not major. Our minor product. This one will become our minor product, and then we have what? We have BRNA or NABR. Why BR? NABR. Here is also what? NABR, and then plus H2O. So this one is the minor product. Minor product I follow Mulawa ZZ. Major product following Mulawa was ZZ. So so now let's move to D. Now let's move to dehydrogenation. We have dehydrogenation. We have dehydrogenation. So in dehydrogenation, what is happening, guys? You must just know what in dehydrogenation, we are going to be 1, 2, 3. We are going to be removing hydrogens. We are going to be removing hydrogens, guys. So we have a product like this. We have a product like this one. And then we have hydrogen, 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 hydrogen. So we will just be removing hydrogens here. We'll just be removing hydrogens, but we follow the Markov, the ZZ rules. Ne? That says we must, when you remove this one, you must take the one with the least. Right. So now, which one are we going to remove? This one, it has 1, 2. This one is 1, 2, 3, 4, 5, 6, 7, 8. And then we are going to be forming what? We remove what? In a catalyst, PT as a catalyst, PT as a catalyst, catalyst, PT as a catalyst. And then now we're going to have 1, 2, 3, 4. And then we are going to be forming single bonds, guys. Single bonds. If we add hydrogens, it's just going to be single bonds all over. And then we have done what? We have added the hydrogen. So this is what we refer as what? As dehydrogenation. This is what we call the dehydrogenation. So from double bond to single bond. Not this one is not right. This one is not correct. So this one is not right, ne? Because I'm D. This one is not correct. Take note of this. In dehydrogenation. In dehydrogenation, what's happening? We have single bonds. We have single bond 1, 2, 3. And then we are going to have hydrogens here. We're going to have hydrogens here. The first one, they explain here dehydrogenation. Just don't take it into consideration. And then this one will form. We eliminate hydrogen. We take hydrogen gas. And then we're going to have 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right. So we are just going to take 2 hydrogen. You can either take these ones or the other ones. It doesn't matter. So the double bond, it follows the ZZ rule. But so the ZZ rule says that the hydrogen that must be removed, it must be removed from 2 carbon atoms. That has the least. So wabana moko remove this one because carbon number 1, 2, then I let 2, 2 hydrogen, you can let 3. So we can remove this one or can remove this one. Either way, it's the same, guys. So we're gonna have hydrogen, 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 hydrogens, hydrogens, hydrogen, hydrogen. Remember, it must be balanced. The one that we removed, we write it here, H2, H2, or you can write it in the form of what? Of bond, H2 like this. So, and then this one is what we call the dehydration, and then the catalyst. The catalyst ya PT, catalyst ya PT. So guys, the one you presenting at dehydration in the first time is not correct. This one is the correct one. Yeah, you are old people, guys. You can know that we also sleep here and there, right? So this is almost everything about elimination. Oh, sorry, not everything. We forgot we forgot cracking. We forgot cracking. Cracking, guys, you know that you are dating, guys, and your heart is being broken so many times. It's been cracked. Someone's heart has been cracked, like in numerous ways. We have catalytic, we have catalytic, catalytic cracking. We have catalytic cracking, not catalytic, catalytic cracking, and then we also have what? Thermal cracking. So we'll be discussing on how many times has your heart been cracked. So let's get to it. Catalytic cracking involve what? Involve a catalyst. It involves the catalyst as what? It involves a catalyst and what? Heat. Whereby this one, thermal cracking, only occur in heat. And high pressure. Guys, don't be so guys, don't take it as so offensive. It's just a joke. Just take it as a joke. All right, thermal cracking is we use catalyst and heat to make it happen, and then heat, we have heat. Thermal cracking is heat. Thermal is from the word heat and word and high pressure. So if ever they tell you about heat and high pressure, you must know that it's thermal cracking. So let's see how much somebody's heart has been cracked. We have 1, 2, 3, 4. We have this single bond. Mama uthumme ayibelegele pelo ituletse sentle. In your bedtime, guys, you had a very full heart without anything, and then there came somebody under the name of love. All right, guys, and then we have what? If ever they say heat and pressure and high pressure, you know that it's what? It's thermal cracking. If ever they say heat and catalyst, you will know very well that it's catalytic cracking. So how are we going to do that? If ever they break it into 2 pieces, 1, 2, and then we have double bonds here, and then it's like this. How are we going to get the next part? We are going to find your next part where? Right, we had 1, 2. In total here we had 1, 2, 3, 4. It's the issue of balancing here. It's 1, 2, 3, 4. So you're gonna say 1, 2, and then we are going to identify how many hydrogen has been used here. We have used 1, 2, 3, 4. Out of how many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of 10. We used 4 out of 10. It means that this one must have 6. 1, 2, 3, 4, 5, 6. This is how we do it. We balance the cracking part. Yeah. This is how we find the product of cracking. You identify how many, if ever they give you this product, you identify how many has been used, depending on the product. But at the end of the day, guys, also balanced equation. You must have the balanced equation at the end of the day. So guys, we are Rainbow Nation, so we just combine languages. Don't get me wrong. So we'll see when we do more questions.